are based on frustum. What is a frustum? If you take a cone and cut it from here, that is a plane. So the shape that will be formed, this shape will be frustum. So a bucket has top and bottom diameters of this much. So bucket will be of this form. So the top and bottom diameters are given. So this is the diameter, because this is also a circle, this is also a circle. And one more thing about the bucket, all the questions which will have bucket, we need to understand that the one part will be open, the other part will be closed. So here the diameter is given as 40, so the radius will be 20. Here the diameter is 20, so the radius will be 10. Find the volume of the bucket if the depth is 12 centimeter. The depth is 12 centimeter. Volume has to be found out. Now we have the direct formula for this. That means volume of a frustum, or you can say volume of the bucket, is given by, because it doesn't matter whether this is free or this is, the sheet is there, the volume remains the same. So it will be this pi by 3 r1 square plus r2 square plus r1 r2 into h. This r1 is this one, r2 is 10, and height is 12. So we put the values here and it will come as 8800 centimeter cube. Now the next part is we have to find out the cost of the tin sheet. Cost of the tin sheet for making the bucket at the rate of this much per decimeter square. Now, in order to find out the sheet, cost of sheet, we need to find out this. That is the slant height of this shape. So the slant height, the formula is under root r2 minus r1 or r1 minus r2, it doesn't matter. It's r2 minus r1 whole square plus h square. H is this 12 square. So when we use this one, see, we have already used this. So 20 minus 10 whole square, because this is the radius, r2 minus r1 whole square plus h square, that is 12 square. And you take the root, this will come as 15.620. Now the formula of this surface, that is the area, that is the total surface area, is pi into r1 plus r2 into L, pi into radius 1 into radius 2 into the L, that is the slant height. And then we have pi r2 square. What is the r2 square? See, when you talk about a bucket, this side is already open, so we will only include this side because this is where the water lies, or whatever is poured here. So this r2 will be 10, this 10. So we are using pi 20 plus 10, then this is the slant height, pi into r2 square, that is 10 square. So this will come 17.87 decimeter square. Now for 1 decimeter square, the cost of the tin sheet is 1.20. And for this much decimeter square, we just have to multiply 1.20 with 17.87. This will come as 21.40. A frustum of right circular cone has a diameter of this much, of top 12, and base is 20 and top is 12, and height is 3 centimeter. Find the area of its whole surface and volume. So again, we know that a frustum is something like this. Actually, it is a cross section of a cone. The frustum of a right circular cone has a diameter of base 20 centimeter. So if say this is 20, of top is 12, say this is top. So diameter is there. So let me make it 10. 20 by 2 and 12 by 2, because these are diameters. So this will be 10 and this will be 6. Okay. And the height is 3 centimeter. The height from here to here is 3 centimeter. Find the area of its whole surface and volume. So volume of the frustum, we know that it is pi by 3 into r1 square plus r2 square plus r1 r2 into h. We have all the values. 10 and 6 are the radius. Just put in here 10 square plus 6 square plus 10 into 6, and this is the height h. Now in order to find out the whole surface, that is, now we need to find out the slant height. The slant height will be equal to under root r1 minus r2 or r2 minus r1, whichever you take, because it is square, so it doesn't matter. So 10 minus 6 whole square plus h square is 3 square. It is going to come as under root 25, which is 5. Now we can use the total surface area. now here it is not a bucket, so it will have this surface which is pi into r1 plus r2 into L, and this surface pi r1 square, and this surface pi r2 square. That is how total surface area will be computed. So here r1 and r2 are 10 and 6, 10 and 6, just computed. It is 678.85 centimeter square. The slant height of the frustum of a cone is 4 centimeter, and the perimeters of its circular end are 18 and 6. Find the curved surface of the frustum. Now the slant height is given, that is L is given. Again. So now this perimeter of the circular end, perimeter means the circumference. So what is circumference of a circle? There are two circles. One is this one, second is this one. So 2 pi r, that is the circumference of the first one is 18. So pi r will be, let us say it is pi r1. Okay, pi r1 and pi r2, pi r1. It is 18 by 2, it is 9. How about the second one? 2 pi r2 is, it is 6. So pi r2 will be equal to 3. So what is the curved surface area? Curved surface area is simply pi into r1 plus r2 into L. That is pi r1 plus pi r2 into L. Pi r1 is 9, pi r2 is 3, and the slant height is already given 4. That is, this height is given. Multiply here. So 12 into 4, that is 48 centimeters square will come. The perimeter of the ends of a frustum of a right circular cone are 44 and 33. If the height of the frustum is 16 centimeter, find its volume, the slant surface, and the total surface. So here again we have a frustum. Now the perimeter of the upper one is 44 and perimeter of here is 33. So this is 2 pi r1 is 44 and 2 pi r2, that is circumference of this one, is 33. This is 2 into 22 by 7 into r1 equal to 44. So r1 will come as 7. Coming to this one, 2 into 22 by 7 into r2 equal to 33. So r2 will come as, this is 33, it will come as, see, it is 11 2s are 22, 11 3s are 33. So 7 3s are 21 by 4. 21 by 4, so it will come as 5.25. R2 is 5.25. Now, the slant height L is under root R1 minus R2 whole square plus H square. So 7 use here because this is 7 and this is 5.25. 7 minus 5.25 whole square in plus 16 square. So the L is, slant height will come as this value. I'll just try to compute it so that we can get the exact value. So this is 7 minus 5.25. So 7 minus 5.25 is equal to 1.75. Okay, and because it is square, so into 1.75, let us do it. 1.75, it is going to be 3.0625 plus 16 into 16. So this will be 259.0625. So we have to take the under root of this 259, or let us say 260. Okay, so let me just compute it. I'll just compute it for you, and that will come as the, I'm opening the calculator. So this is a root of 260. Let me take it as 260. Okay, so 260 under root of 260 is 16.12. So this is the answer, L. Okay, now we have the slant height also. Okay, find the volume, the slant surface, and the total surface. So volume is simply 1 by 3 pi r1 square plus r2 square plus r1 r2 into h. This is 7, this is 5.25, and then h is 16. Right, see, the height is given as 16, but the slant height is 16.1. Right, actually it is 16.12. So this we are going to use, just compute it. It will be 1898.56. But here, when we find out the curved surface area, it will be pi into r1 plus r2 into L. This is 7 and this is 5.25. right? Just add it, and L has to be used as 16.1. And the total surface area is what? You have already computed this one, okay? So just keep it here, and you have to add pi r1 square plus pi r2 square. That is, this is the curved surface area, then you have to add this part and this part also. So pi r1 square plus pi r2 square, r1 is 7, r2 is 5.25, and computed it will be 860.27 centimeter square. If the radius of the circular ends of a conical bucket, which is 45 centimeter high, is 28 and 7, radius is given, find the capacity of the bucket. So already the r1 and r2 are given, and height is also given. So we use directly the formula, pi by 3 r1 square plus r2 square plus r1 r2 into h. So just put in here 28 square, 7 square, and 45. This will come as this value. If the radii of a circular end of a bucket 24 centimeter high are this much and this much, it's a bucket, so it will be something like this. Now the radius here is, from here to here it is 15, from here to here it is 5, and what is the, and bucket 24 centimeter high, 24 is the height. Find the surface area of the bucket. Surface area of the bucket, because this side is open, so it will be curved surface area, that is pi into r1 plus r2 into L, plus this surface, that is pi into 5 square. This will be 5 square, okay, pi into 5 square. So we have to find out this slant height. R1 is given, R2 is given. So we find out the slant height under root R1 minus R2 whole square, or R2 minus R1 whole square plus h square. So 5 minus 15, or 15 minus 5 whole square plus 24 square. So L will come as 26. So you have to use 26 here. So pi into 5 plus 15 into this L, which is 26 we found out, and pi R2 square. Now this R2 has to be 5. So 5 square should be there. So it will be, you just have to add 25. So 520 plus 25, it will be 545. 545 pi. This will be 545 pi. This is the only difference. The radius or radii of circular bases of a frustum of a right circular cone are this much and this much, and height is 15 centimeter. Find the total surface area and the volume of the frustum. So again, the main thing is, because the radius is already given, r1, r2 is known to us, and the height is also known to us, height is 15. The only thing is to find out the slant height. Slant height will be r2 minus r1 whole square plus h square. That is this 12 minus 3, that is 9 whole square, that is 81, and h square 15 square, or it is actually, the height is 15 square, right? So 15 square will be, if it is 15, if it is the slant height, because slant height has to be found out, and the height is 12, so let us use it as 12. It is 12. So 12 square is what? 144. 81 plus 144, and under root is, this will be 225, and it will be 15. Now we have the formula for the total surface area, pi into r1 plus r2 into L, and pi r1 square plus pi r2 square. This is 12, this is 3, and L we found out to be 15. Now we'll use 12 here and 3 here, and then 378 will be the total surface area. When computing the volume of the frustum cone, it will be 1 by 3 pi r1 square plus r2 square plus r1 r2 into h. So put all the values, we know that will come as 756 pi, and it will be, this will be in square units, this will be in cubic. Of a frustum of a cone capped by a cone. So we have a proper cone here. If they, like this, up till here we have a frustum, then we have this cone. If the radii of end of frustum is 13 and 7, so this will be 7, and this will be 13. The height of frustum be 8 meter. So height of frustum is, this is 8 meter from here to here, frustum. And the slant height of conical cap is 12 meter. So this is 12 meter. This is 12 meter. Find the canvas required for the tent. So we have two parts here. One is cone, the other one is this frustum. So what we can do, first of all, we will find out the certain parameters which is required. Because we have the radius of this frustum, two radiuses, and the height, we can find the slant height. So this L or slant height can be found out using this formula, R1 minus R2 whole square plus H square. So R1 is 13, R2 is 7, say 13 minus 7 whole square plus 8 square, you take the under root, it will come as 10. So this is 10 now. This is 10. Okay. Now, we have to find out because it is already given that the cone slant height is given. So, the area or surface area of this cone will be pi into R into L. We already know the radius, so 7 is there. We already know the slant height, so 12 is there. So, it is already given to us. And what is the surface area of this frustum? It will be pi into R1 plus R2 into L. Pi into R1 plus R2 into L. This is 13, this is 7, and this is 10. This is, the height is 8, sorry. Oh, sorry. This L is 10. I'm so sorry, 10. So 10 is there. So you just multiply by 10. Now this comes to be 200 pi for the curved surface area of the frustum. And curved surface area, not total surface, curved surface area we have to find out, because the tent will be formed, the tent will consist of the curved surface area only. So curved surface area of the upper cone cap will be pi Rn. So pi into 7 into 12, this is 264, just add these two, you are going to get total canvas as 892.57 meters squared. A bucket in the form of a frustum of a cone with a capacity. Now we have a bucket and the capacity is given, that is the volume is given. Radii of the top and bottom of circular ends are 20 and 12. So this is 20 and this is 12. Find the height of the bucket. So height needs to be found out. And the area of the metal sheet used in making. So first we'll find out the height. What we'll do, we'll just equate the volume equation of this bucket with this 12308.8. That is 1 by 3 pi, R1 we know it is 20, R2 we know it is 12, R1, R2 we know, and height also we know. Height we don't know, sorry. Height we have to find out. So we compare it, or we just compute it and compare it with the 12308.8, and height will be 15 centimeter. The calculation is in front of you. Now, we have to find out the area of metal sheet. That is, we have to find out the curved surface area first of all. That is the pi R1 plus R2 into L. And then this area of the bottom, because this area of the bottom, above area bucket, it is a bucket. So above area will not be there. Only the bottom area will add. So we'll add pi R2 square. So pi into R1 plus R2 into L plus pi R2 square. So now we need L. We need the slant height. But it is quite easy because we have all the things. Height we just found out, and the R1 and R2 we know. So we just find out L square equal to R1 minus R2 whole square plus H square. This is 20 minus 12 whole square plus the 15 square, and this L will come as 15. Now put it here. This is 17 will come. 17 is there, 20 and 12, and this will be 12. When you compute, it is going to come as, the curved surface area will come as 2160.32 centimeter square. Okay, a bucket made of aluminum sheet of height 20 centimeter, and its upper and lower ends are having radius 25 centimeter and 10 centimeter. Find the cost of making if the aluminum sheet cost rupees 70 per 100 centimeter square, that is rupees 70 by 100 for 1 centimeter square. Okay, so we have a bucket again, and for this bucket, this portion will not take, only the bottom portion we are going to take, and the curved surface area. For that, the height, sheet of height, so height is given 20. Upper and lower radiuses are also given, so this is 25 and this is 10. So we have 25 and 10. Now we have to find out the L, that is the slant height. So this slant height will be R1 minus R2 whole square plus H square, that is 25 minus 10 whole square, plus H square, that is 20 square. So this will be 25. And then we know the curved surface area of the bucket, a pi into R1 plus R2 into L we just found out, and pi R2 square, that is the bottom one, pi 10 square. So we have all the values. This will come as 3061.5. Now for 1 centimeter square, it is 70 by 100, that is 70 per centimeter square. So for this much centimeter square, what will be the answer? Just multiply this by 70 by 100. and this will come as 2143.05 rupees. Radii of circular ends of a solid frustum of a cone are this much and this much, and its slant height is 10 centimeter. Find the total surface area. So total surface area is simply pi into r1 plus r2 into L plus pi r1 square plus pi r2 square. Let me make it. So this area, that is pi r1 square, this area pi r2 square, and then the curved surface area, which is pi into r1 plus r2 into L. All the values are known. This is 33, this is 27, this slant height is already given 10, and r1 r2 of course we'll use it again, and this will come as this value, total surface area. A bucket made up of metal sheet is in the form of frustum of a cone of height 16 centimeter with diameters of its lower and upper end this much. Find the volume of the bucket. Also find the cost of the bucket if the cost of metal sheet used is rupees 20 per 100 centimeter. That is, for 1 centimeter it will be 20 by 100. Okay. Now, first of all, we have a bucket again. Sheet in the frustum of height cone. Height is 16. From here to here it is 16. Diameter of its lower and upper. So this diameter is 40. So radius will be 20. 40 by 2. This diameter is 16. So it will be 16 by 2, 8. 8 is the radius. Find the volume of the bucket. So volume of the bucket will be 1 by 3 pi r1 square plus r2 square plus r1 r2 into h. All things are given to us. All things are given to us. You just compute it. The volume will come. Now volume is computed now. Find the cost of the bucket. So for that we need to find out the curved surface area of this frustum. That is curved surface area. That is actually total surface area. It should not be curved surface area. It should be total surface area. Why? Because curved surface area is this one. Total surface area is, we are including this one also. Right? That is, this is the total surface area. So first of all, we have to find out the slant height. Slant height formula is r1 minus r2 whole square plus h square. This is 20, this is 8, this is 16. So it will come as 20. So we have the 20 as the slant height. But we know the formula of the total surface area, that is pi into r1 plus r2 into L and pi r1 square. R1 will be 8. So just compute it, 624 pi. Now 1 centimeter square is 20 by 100. So how many of this will be? 624 pi, it will be 624 pi into 200 by 20 by 100. That is, the cost of the metal sheet will be something in this rupees. That is 391.9, 392 rupees. A solid shape of frustum of a cone. The diameter of two circular ends are 60 and 36. Height is also given. Find the whole surface and the volume. That is, again we have to find out L. We know the formula for volume. We know the formula of total surface area. So we have the, let me make it for you so that you understand what we are doing. The diameter of two circular ends. So this is diameter, so 60 by 2, 30 is the diameter here. 36 by 2, so it will be 18. Height is 9. So now first we'll find out the slant height, r2 minus r1 or r1 minus r2 whole square plus h square. That is 30 minus 18 whole square plus h square, that is 9 square. So it will come as 15. Now volume of the first frustum will be 1 by 3 pi. This will be 30, this will be 18, 30, 18, and height is already known, 9. So just put it here. This will be volume. Now coming to the total surface area. So this is this will include both the parts, this one, and the curved surface area. Curved surface area is pi into r1 in r plus r2 into L, and these two surfaces will be pi r1 square plus pi r2 square. So this r1 is 30, r2 is 18, 30, 18, this will be 15 we just found out. Computed, it will be 1944 pi. A milk container is made up of metal sheet. So milk container means it will be closed from both the sides. Metal sheet is in the shape of frustum cone whose volume is given. Here volume is given. The radii of top and lower are 8 and 20. So let me just assume that it is flipped over. Okay, I made it flipped over. So this is 8 and this is 20. So it has to be other way around, right? So 8 and 20. Find the cost of metal used in making container at a rate of 1.40 per centimeter square. So we have to find out the total surface area. We just multiply it by 1.40. So what will be the total surface area? It will be pi into r1 plus r2 into L, pi r1 square plus pi r2 square. We know all the values, 28 and 28. L has to be found out. L we don't know. So for that L, what we are going to do, first of all, we have to find out the height, then only we can go to L. But here we have been given the volume, but height is not given. So height will be computed using the volume. So what is the volume? 1 by 3 pi r1 square plus r2 square plus r1 r2 into h. H has to be found out. We'll equate it with 10459. Okay, when you equate it, you'll get height as 16 centimeter. The 16 centimeter is height. Now we'll use the formula of slant height to find out the slant height. R1 minus R2, 20 minus 8, and this is height, so 16 square. L will come as 20. So just put in here 20. Everything is known. It will be 3216.99. Now 3216.99. If this is the answer, total surface area, we have to find out the cost. So you have to multiply this with 1.4. So I just assume that this is 3217. Okay, 17, and I multiply it with 1.4. This is going to come as 4503.8. So you can just assume 4504 rupees. A reservoir is in the form of a frustum of right circular cone, contain this much of liter of water, which fills it completely. So volume of that reservoir is given. The radii of bottom and top are 50 and 100. So again, this is 50 and this is 100. Find the depth of the water. So depth can be found out using the volume. So height has to be found out. And the lateral surface area of the reservoir. So let us find out. First of all, the depth of the frustum, volume is given. Let us assume it to be h, depth or height. So 1 by 3 pi r1 square plus r2 square plus r1 r2 into h is the volume. R1 is 50, R2 is 100, and h we don't know. We take this formula and equate it using 44 into 10 to the power 7. When we equate, h will come as 24. So height is known. Height is known. Okay, now let me come. So I'll just write the formula, and I expect you to do it, So the lateral surface area, that is the curved surface area. Lateral surface area is curved surface area. Total surface area is the total area. So lateral surface area will be pi into R1 plus R2 into L. Now this L has to be found out using this hundreds minus 50, that is R1 minus R2 whole square, plus the height square, 24 square. This L has to be found out, and here you have to use 22 by 7. R1 plus R2 is 50 plus 100 into this one, under root 100 minus, I'll just write 50 square plus 24 square. So I hope you'll be able to solve it. This is the answer. Next is a metallic right circular cone. So here we have a metallic right circular cone, 20 centimeter high. So from here to here it is 20 centimeter, whose vertical angle is 90 degrees. So this angle is 90 degree. This is 90 degree. It's cut into two parts. So at the middle point of its axis by a plane parallel to the base. So there is a plane which is cutting it exactly in between. If the frustum so obtained be drawn into the wire of diameter 1 by 16 centimeter, it is quite low. So a very long wire will be formed. So 1 by 16 centimeter. Find the length of the wire. So we'll find out the volume of this one and equate it with the volume of this one. That is the wire. Wire is nothing but a cylinder, very small cylinder. Length has to be found out. That is let us say it is h or L. And then the radius or the diameter is given. The diameter is 1 by 16. So radius will be 1 by 16 by 2. That is 1 by 32. Okay. First of all, we are not being provided the radius here of either this part or this part. So we'll use the trigonometry here. So this is from here to here, it is 10. Why? Because this is cut, the height is 20 total, and it is cut in between. So this is 10 and this is also 10. So now I'm using this triangle. See this triangle. This is 45 degree because it is 90 degree, half will be 45 degree. So 10 45 will be what? EO perpendicular by base, that is this AO. 1045 is 1, so we get what? EO equal to AO. and AO is what? 10, half of it. So this EO will be 10. That is our R1 or R2, whatever you say. Because you can take R1, R2, it doesn't matter. Then we have this triangle, this total triangle. That is triangle ABD. In this triangle, again this is 1045 degree. 1045 for this triangle will be perpendicular by base. So BD. So let me write it directly as R2. BD is R2. This is R1, this is R2. R2. By this one, total AD is what? 20. 1045 is 1, so R2 will be 20. So R2 is 20. Now we have R1 and R2. R1 and R2. Now we have the formula of the volume and we'll equate it with the volume of this the other wire. So 1 by 3 or pi by 3 into R1 square, that is 10 square plus 20 square plus R1 R2, that is 20 into 10, and what is the height? It is 20. This is equal to the volume of this cylinder will be pi r square h. So pi into r square, what is the radius? 1 by 32 into h. H has to be found out. L has to be found out. Actually, h and L both are same. So pi I cancel it out. So this will be 10 square is 100. 20 square is 400. 20 into 10 is 200. 20 is there into 20 by 3. And this 32 square will go here. So 32 square will go here. This will be the height. So let me compute it for you. 400, 200 is 600. This is 700. So 700 by 3 into 20 into 32 square. This is height. So this will come a very, very big number. Okay, so you have to make it in meter, or if you want, you can convert it into kilometer also. So this is 32 into 32. So 32 and x square is 1024. So this is 1024. And then this is 7,000. So multiply it by 7,000. So multiply by 7,000. 7,000. This will come as 7168000, and we have to divide it by 3. So divide by 3, and this will come as 2389333.33. It's a big number. So this is in centimeters, so you can convert here, say meter. Even if you want, you can convert it into kilometers. So it will be 24, around 24 kilometers. It will be very, very long wire. So this is all about this exercise. Thank you so much. Take care of yourself.